The angle of elevation between the 6 o'clock position and the 12 o'clock position of a historical building's clock, as measured from an observer standing on a hill, is pi over 444. The observer also knows that he is standing 424 meters away from the clock, and his eyes are at the same height as the base of the clock. The radius of the clock is the same as the length of the minute hand. If the height of the minute hand's tip is measured relative to the bottom of the clock, what is the height of the tip at 5:08 to the nearest tenth of a meter? Let's outline a strategy that can be used to solve the problem. First, use basic trigonometry to calculate the height of the clock using the given diagram. The radius of the clock is the same as the length of the minute hand. Divide the clock height by 2 to get the length of the minute hand. Model the movement of the minute hand with a trigonometric function. Finally, use the function from step 3 to calculate the height of the minute hand's tip at 5:08. Let's begin with the first step in our strategy. Redraw the triangle. Use tan theta equals opposite over adjacent. Replace the angle with pi over 444 and replace the adjacent side with 424. Cross-multiply to get the opposite side. The opposite side is 3 meters. Now we'll move on to the second step in our strategy. The radius of the clock is the same as the length of the minute hand. Divide the clock height by 2 to get the length of the minute hand. The minute hand is 1.5 meters long. Next, model the movement of the minute hand with a trigonometric function. Time goes on the x-axis and the height goes on the y-axis. Introduce ticks on the time axis. Introduce ticks on the height axis. The animation shows the height of the minute hand's tip over 1 hour. The vertical displacement is 1.5 meters. The amplitude is 1.5 meters. The period is 60 minutes and the b value is pi over 30. There is no phase shift. The function is h of t equals 1.5 cos pi over 30t plus 1.5. Finally, use the function from step 3 to calculate the height of the minute hand's tip at 5:08. At 5:08, the t value is 8 minutes and the height is found by plugging 8 into the cosine function. Plug in 8 minutes for the time. The height of the minute hand's tip at 5:08 is 2.5 meters.